Hey guys, Mr. Gran here, 7.3, proving triangles similar. In this video, we are going to go over the different similarity theorems and do one quick example. All right, so when it comes to proving similarity, much like proving congruence, we don't need to know that all three sides and all three angles are equal in order to know that two triangles are congruent. Same thing with similarity. We don't necessarily need to know that all three sides are proportional and all three angles are equal in order to know that two triangles are similar. One way to do it is side, side, side. If we know that we've got three proportionally similar sides, then we know that the two triangles are similar. So in this case, for side, 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 if we took and did the long sides, right, so we did 25 over 15, is that equal to the medium sides, 20 over 12? And is that equal to the short sides if we do 15 over 9? If all three of these things reduce to the same number, that means that all three sides are proportionally similar, and that means that these triangles are both similar. We know for a fact that the corresponding angles are going to be equal. All right, we can also do side, angle, side. And so in this case, I would want to show, it's given that F and J are both congruent, and so if the sides around them are proportionally similar, then the triangles are going to be similar. So in this case, what I would want to do is take the longer side, right? Always think about matching up the longer sides and the shorter sides and the medium sides so that they're corresponding. And then I would want to take the shorter side, so 15.4 over 14. And if those two ratios are the same, if these reduce to the same number, then these two triangles are similar by side, angle, side. Then our last one, angle, angle. Now notice it's just two angles, because if it's a triangle, there's automatically 180 degrees. So if I know that two of the angles are equal, well, then the third one must also be equal because they all have to add up to 180. We can kind of show this with this example. I'm given that Q and T are both congruent to one another, and I'm not given the same angle with the other one. But if I go 180 minus 100 minus 45, I get 35 degrees. And so that means that R is congruent to U. And if I did the same thing over here, if I subtract these two from 180, I'm going to get that this is 45 degrees. All three angles are equal, but I didn't really need to take that last step and show that this is equal, right? If I can show that two of the angles are equal, then I know that the two triangles are going to be similar. All right, so quick example. We got some overlapping triangles, right? What I want to show here, let's take a look at this. So I want to see, is ABC, this must be the pre-image, similar to A prime, B prime, C prime, the image. So what I want to do is sort of take out this triangle, right? I'm going to re-sketch it over here as best I can. And that's ABC, and that has single arc, double arc at B. Well, now if I do the same thing, but I redraw the whole thing there, right? So it's bigger, and it looks like that, and that's our A prime, B prime, C prime. Well, if I put the same things, right, I've got still got a single arc up here, I've got my double arc down there. Now if I look at those separately, this works. These are similar by angle, angle similarity. So that, what is the theorem that shows ABC is similar? That would be angle, angle.